Hello, everyone. Mr. Schultz here as we dive into the idea of complex numbers. So, our objective today is to perform operations with complex numbers. What does this mean? Well, like add, subtract, multiply, divide with complex numbers. So, if we look at this right now, we have this Venn diagram of real numbers and imaginary numbers. Complex numbers involve all of these. So both these together would be complex. A being a real number like 5, and then we could do like 5 plus 2i. There's an imaginary plus a real. Boom, it's complex. So when b is 0, so 0 times I, that gets rid of that I, imaginary number. Now, hey, look, it's just real. Now, if we want pure imaginary, so pure imaginary would be, pure imaginary. So we go pure imaginary. That's if a is 0. Because what's 0 plus an imaginary number? Just that imaginary number. And so remember the imaginary number, negative, the square root of a negative 1 is equal to I. It doesn't really work because if we try to figure out like the square root of 4, it's both 2 times 2 as well as negative 2 times negative 2 will equal 4. But negative 1 times 1 equals not negative 1, 1, and negative 1 times negative 1 equals not negative 1, but 1. So it doesn't work out. So that's a preview from last video. So let's go on. So in other words, it has both real and imaginary parts. So let's dive into this complex conjugates. So if we have a plus bi and we're going to have a minus bi, the product's going to be a real number. But why? Let's jump into that before we go into the nitty-gritty of everything. I'm going to set up my multiplication grid. So let me draw it right now. So I'm going to have my square, and then I'm going to put my little squares inside it. So let's try an easy one. Let's do 2 plus I. So 2 plus I, and then let's have 2 minus I. So if I go like this, 2 times 2 is 4. 2 times I is 2i. And 2 times negative I is negative 2i. Now we might be like, hey, look, 2i minus 2i will cancel out, and we're left with 4. But then you go, wait, what about those i's? We still have to multiply them. Well, what's I times I? If you remember from last time, I squared is what? Give you a second in 3, 2, 1. Well, I squared times I squared, I times I is going to give us negative 1. Because we have that like negative 1 times negative 1, so that will equal negative 1. But since there's a negative inside there, negative times a negative, so this guy, if we substitute that guy in there, a negative times a negative is 1. So now I have 4 plus 1 is 5. So if I have 2 plus I times 2 minus I, it's going to give me 5, a real number. So remember, there's a few things. The conjugates will take care of that middle number away, get rid of those. So those i's will go away. They cancel each other out by adding the opposite. And then that I squared becomes a negative 1, which is positive 1. All right, let's go on to our second page. So it says equate complex equations. So find the values of x and y that make this equation true. So let's hold up while we show our work. All right, so these two expressions are going to be equal to each other as long as the real parts are equal to the real parts and the imaginary parts are equal to the imaginary parts. So there's like two different equations right here. So if we break it up, we have two different. We have the black and the purple. The black being the real parts. So I'm going to write this down. 5x minus 7 is equal to 13. So now I can solve for x. If I add 7 to both sides, using the addition property of equality, I get 20 is equal to 5x. And now I just need to do the opposite of times, which would be divide by 5 on both sides using the division property of equality. And so I realize that x has to equal 4. But wait, there's the other half of this expression that we need to talk about. We have the imaginary parts. Now we can take these imaginary parts and put them to the side, and we know that y plus 4 has to equal 11 because these imaginary parts have to be equal. Well, what plus 4 is equal to 11? Everybody and their mother should be able to get it, but just in case you don't, let's subtract by 4 on both sides and get 7 is equal to y. So in this situation, the value of x should be 4 and the value of y should be 7. What we did was we separated the real parts from the imaginary parts and we solved each of them separately. That's how you do it. Let's go on. So add or subtract complex numbers. So once again, we can do the following. Let's set it up. Well, first we're going to do is we're going to understand that, hey, we get complicated up when we try to subtract things. So we're going to change it to add the opposite. So this becomes plus, and everything in here becomes a negative. So this is a minus 4, and this is a plus 10i right there. And now we just have to add the real with the real and the imaginary with the imaginary. So I have 8 minus 4, and then I'm going to add that to 3i plus 10i. All right, so I should get 13i plus 4. So there's always been this gripe like, hey, was there an equal sign? Then why do you put equal signs? Well, if we have an equation, but in this case, this is not an equation, this is an expression. So some people might be like, well, we should put an equal sign, but no, it's an expression. All right, let's go on. I do believe the next one is multiplying complex numbers. So I'm going to show you one and try to show you my work as I'm doing it. And I want you to follow along, and then I'm going to give you the answer to the next one after you pause it. If you think you got this, go ahead and pause in 3, 2, 1. So we showed you the multiplication grid above, but let me teach you about the FOIL method as well. I don't really like this one. I used to love it, like every day I'd be like, all right, let's use this FOIL method. But now I'm like, meh. And we're going to be talking about it like the claw. If you're trying to do the FOIL method, it should look like a claw. Look at this. We're going to multiply the firsts. So if we multiply the first, we get 6. And the next one is the outsides. 2 times minus I would be minus 2i. And then we do the inside. So I times 3. So now that's plus 3i. and we do the last, which is I times I. But it's negative, and I times I is -1, and -1 is +1. So now what do we have to do now? We have to simplify. We have to put them together. So I have 7 plus I. There we go. Now we'd get the same thing, and I'll show you in just a second my work. So hold up. I'll do the multiplication grid. So we get the same thing, but it's just set up differently. I like this one because it's more of a conceptual idea of multiplying. So I would recommend doing it this way. Let's set you up. Go ahead and make your grid, and I'm going to stop it in 5, 4, 3, 2, 1. So this is what I get with multiplying, having my multiplication grid. And now I can just rewrite it and add it like I'm reading it. I have 12, I have 10 i's, and I have a -2. But wait, I can simplify. So this becomes 10 plus 10i. All right, let's divide some complex numbers, all right? Let's go on in 3, 2, 1. So on this one, what we're going to do, what we kind of want to do is we want to rationalize this denominator and not have any imaginary numbers downstairs. We want to get them out of here. So hold up. Let me set you up and let's go. So I've now set it up. And remember, if we're multiplying by the conjugates, it gets rid of that imaginary number. It's only left with real numbers. So if I multiply this, what I'm going to get is something a little different. I'm going to pause and show you with a multiplication grid. But on the top one, let's do the top one right now. Remember, I'm not multiplying by anything right here. I'm just multiplying by 1. Well, because what's 5 divided by 5? 1. What's 3 minus I divided by 3 minus I? 1. Any number divided by itself is 1. So if I did the top, this is what I would get. I would get 15 minus 5i. And now let's show you the work so you can believe me when I show you the solution. So showing my multiplication grid, 3 plus I times 3 minus I would be 9 plus 3i minus 3i plus 1. So these cancel out, and 9 plus 1 is 10. So now I just put this 10 up here. Now what I can do is I can simplify a little bit, which I will. So what I'm going to do is I'm going to move the real parts away because they don't want to hang out. Some of them are real, some are imaginary. You know, your real friends don't want to hang out with your imaginary friends, okay? So separate them a little bit. So 15 divided by 10 is 3 over 2. Divide by 5, divide by 5. And then 5 tenths is 1 half. So it'd be 3 halves minus 1 half I. So now I have a complex number that's a little bit easier to work with. 3 half minus 1 half I. All right, I'm going to give the solution to the next one. Not going to show the work, but I'm going to give you the solution. I want you to try to get it. So I'm going to show the solution in 5, 4, 3, 2, 1. All right, now I want you to try to show your work to get to there. All right, you guys have a wonderful day, and I'll catch you in class.